Hello viewers, my name is Mr. Kazim and I am delighted to welcome you to my YouTube channel at Smart Edu TV. Here you will find detailed tutorials on your science courses and tips on how to answer examination questions successfully. I started this channel to also share my knowledge and experience in this field and to give you tips on how to succeed as a university student. If you are looking for detailed tutorials on physics subjects, chemistry, mathematics, biology, statistics, and the general studies (GST), then you have come to the right channel. So therefore, sit back, relax, and join me on this journey. Don't forget to hit the subscribe button and turn on the notification bell to never miss on an important update. Please remember to also share this video so that others can benefit. Thank you very much. Good day viewers, welcome back to our YouTube channel at Smart Edu TV. Today we are going to be looking at micrometer screw gauge. We want to see how we can use micrometer screw gauge to determine the diameter of a given rod. We want to see how we can use a micrometer screw gauge to determine the diameter of a rod. The first thing we are going to do is to check for the zero error of the instrument we want to use. This is our micrometer screw gauge, so I want to check for the zero error of this instrument. How do we do that? For us to do that, let's try to close the jaws. Let's try to close the jaws and let's see whether it's going to be resting on point 0 on the micrometer screw gauge. So we are trying to close the jaws. Okay, I've closed my jaws. As you can see, it is resting at what? At point 0. Can you see it? On this side. You can see the point 0 on this side. It shows that it's actually resting at what? At point 0. So it's resting at what? At point 0. This shows that there is no zero error attached to this instrument. There is no zero error attached to this instrument. Okay? So the next we are going to look at is to calculate the least count on this instrument. How do we calculate the least count on this instrument? For us to calculate the least count, look at the smallest division. The smallest division on this instrument. Let's check the smallest division. You can see this, that's point 0. So each of the lines are 1, 1. So after 0, we have, you can see 0.5 there, the next one. But if you notice, if you look at under, let's look at under, you can see some scales division under. It means between 0 and the first line. If you check under, there is a tiny line, a tiny scale in between that 0 and 1. That signifies 0.5. That is halfway in between 0 and 1. So it means that the smallest division on this instrument is 0.5. So we are going to use that in calculating our least count. So this will give us 0.5 divided by, then if you look at this scale, this thimble, let's look at this thimble. You can see, I want to look at the numbers. I want to look at the maximum number it has. This is 30. Let me start from 15. That's 15. It has more than 15. 20, 25, 30, 35, 40. After 40, I have 45. You can see after 45, it has some like 5 lines. That's 46, 47, 48, 49, 50. 50 coincides with what? With that 0 mark. It coincides with what? With that 0 mark. So because of that, the highest number it has here on the thimble scale is 50. The highest number it has is what? 50. You can see. After the 45, I have what? 5 lines again to make what? 50. So it means the highest number it has is 50. As you can see it clearly, you can see after that 45, you can see that 0. So that means that 45, 46, 47, 48, 49, then 50. So that means the highest it has is 50. So for me to calculate my least count, I'm going to divide 0.5 by 50. If we do that with our calculator, this will give us 0.01 in millimeters. So that shows that the least count on this instrument is 0.01.
as you can see, it is actually what indicate. You can see it as 0.01 millimeters. This indicates the least count on this instrument. So after getting our least count, the next thing is now what? To start what? Our measurement. I want to know the what? The diameter of this rod. I want to know the diameter of this what? Rod. Don't forget, we use the micrometer screw gauge to determine the external diameter of an object. So I want to use it to determine the external diameter of this rod. How do we do that? So I'm going to what? Close the jaws of this micrometer screw gauge. I want to close the jaws of this micrometer what? Screw gauge. Don't forget, I want to do it in what? Maybe let's say 5 different positions. Maybe the first time when I'm closing it around this point. So I'm still trying to close. I'm trying to close. As you can see. I'm trying to close. Okay, so that means I've closed. You can see. Don't forget, I've closed it, but it has to be gently. So don't over close it. Just do it gently so that you won't cause any harm to the instrument you are using. So I've closed it gently, so you can see it is firmly gripped. You can see it's not falling down. Without touching it, it's not falling down. So this is what? This is my first point, or the first position. That's what? 1.00. Don't forget, on your table you should have what? The same place of what? Decimal. That's why I included 1.00. So the next thing we are going to look at, I want to what? Read this main scale. The first scale here is called the main scale, while this second one is called the what? Thimble scale. This is thimble, while this is what? Main scale. Either you call it this is the main scale, either we call it the main scale or we call it sleeve. They mean the same thing. So on my main scale, I want to see what it has. So let's look at it closely. I want to see what it has. You can see after the 0, I have one line. From 0 to the first line, that's 1. Then from that first line to the second line, that's what? 2. But it's more than 2. Then if you look at under, you will see what? A tiny line that surfaces. That means it is between what? 2.5. It's not up to what? 3. Look at it again closely. Look at it closely again. From 0 to the first line. Then from that first line to the what? Second line. You can see. Then under, you see what? A tiny line. So that's what making it 2.5. So on the main scale, I'm having 2.50. 2.50 on the main scale. On the main scale, I'm having what? 2.50. Don't forget, all readings are in what? Millimeters. So let's now go to the what? To the thimble coincidence. How do we get the thimble coincidence? I want to see. You can see on this main scale, there is an horizontal line. You can see that shoots out. This horizontal line, this is what I mean. So I want to see where this horizontal line aligns perfectly with any of the scale from the thimble scale. I want to see where this horizontal line aligns perfectly. They form perfect alignment with what? With the thimble scale. So if you look at it very well, you are going to notice that it goes beyond 40. That means the first line after what? After 0.40. Can you see it very well? Look at it. The first line after what? 0.40. Can you see it? So that's the point of what? Coincidence. So that's 41. Since each of them is 1. You can see that's what? 41. The first point after what? 40. So that's 41. So there is an alignment on 41 on this scale. Can you see that? Okay. So that means my coincidence is 41. My coincidence is what? 41. So the point of coincidence is what? The thimble coincidence is what? 41. 41.00. So that they will be in the same places of what? Decimal. So for me to get my thimble reading is gotten by multiplying the thimble coincidence by the least count of this instrument. Our thimble coincidence is 41. Our least count is 0.01. So I'm going to multiply 41 by 0.01. So while we do that, let's see what we are going to have. I want to multiply 41 by 0.01. So we are going to have what? 0.41. We are going to have 0.41. So that's our thimble reading. 0.41. 0.41 in millimeters. All readings are in what? Millimeters. So for me to now get what the diameter of this first position, it means I'm going to add the main scale together with the what? Thimble reading or the thimble scale. I want to add the two of them together, that is the A plus what? B. I want to add the two of them together, that is 2.5 plus 0.41. 2.5 plus 0.41. So let's see what we are going to have. When we add that together, let's see what we are going to have. So when we do that, we are going to have 2.91. It simply means the diameter of this first position is 2.91. The diameter of the first position is 2.91. Don't forget. Okay, so the next one, you can see we've seen the what? The final diameter of that first position to be 2.91 millimeters. So we are going to the second position now, which is position 2. I'm going to adjust this, my rod. Adjust it the way you like. Adjust it in such a way that this jaws is going to grip any position on this rod. Any position on the rod. It can be up, it can be down, it can be middle, anyone that is convenient for you. Adjust this in such a way that it can what? It's going to what? Grip another what? Another different position entirely. So let me do that. I'm trying to what? Close my jaws. I'm trying to close my jaws. So when we close the jaws, yes, I've closed my jaws. You can see, I've closed my jaws. You can see it's firmly gripped. It's firmly what? Gripped. Okay. So I want to read the what? The main scale of this position 2, the second position. The main scale of what? Of the second position. Let's go back to our what? Instrument. The main scale of the what? Second position. You can see, if you look at this very well, you will notice that it's also what? Stopping what? 0.2. Also what? 2.5, because there is a what? It is in between that second one and the third one. It's in between the second one and the what? And the third one. So let's look at it very well again. Can you see it? After 0 to the first line, that's 1. After that first line to the second one, that's 2. It goes beyond 2. Then if you look at under, you see what? A tiny line, the third tiny line. The third tiny line, which is a what? Each of the line is what? 0.5. So that means after 2, we have what? One tiny line under, making it what? 2.5. 2 plus 0.5 will give us what? 2.5. So for the second reading, we are also having 2.50. 2.50. For the thimble coincidence, so let's check where the what? When the thimble coincides. We want to check where the thimble what? Coincides. So at this time, don't forget, this is what? 0.40. It goes beyond 40, 41, 42, around 43. But it is in between 42 and what? 43. I think it's in between 42 and 43. Let's look at it very well. In between 42 and 43. So you can pick what? 42.5. We can pick 42.5. 42.50. Okay. So that's our what? Our coincidence. For the thimble reading, don't forget, we are going to multiply this 42.50 by the least count of this instrument. 42.50 by the least count of this instrument. So 42.5 times what is the least count of this instrument? 0.01. 0.01. So when we multiply that together, we are going to have 0.425. 0.425, approximately 0.43. So we can have this as 0.43. 0.43. Then for the diameter, so let's now what? Find the diameter of this second position. So get the diameter of this second position. Don't forget A plus B. That means that is the main scale of the second reading plus the thimble reading of the second reading. 2.50 plus 0.43. So when we add this and this together, it will give us the diameter of this second position. So 2.50 plus 0.43. This will give us 2.93. So for my second position, I'm having 2.93 millimeters. All of these are in what? Millimeters. So this is how we determine the diameter of any given rod using micrometer screw gauge. So you can do it. The same thing applies for the third position, the fourth position, and what? And the fifth position. And the rest is a what? Story. Thank you.